Hello and welcome to my channel. We are on part 2 of day 10 of Kaggle's 30-day machine learning challenge, where we will solve exercise on underfitting and overfitting. Recap: you have built your first model and now it's time to optimize the size of the tree to make better prediction. We have to run the following cell to set up the environment for execution of exercise. We have to import pandas as PD. We have to, from sklearn library dot matrix, we have to import mean absolute error. From sklearn model selection, we have to import trend test split. From sklearn dot trees, we have to import decision tree regression. We are storing the path of the file in Iowa file path variable. Using pandas.readCSV function, we are reading the CSV file and storing it in a data frame home data. We are segregating the predictive feature using home data.salesPrice in a variable y. We are creating a feature list, so the list contains the number of features which will be used for prediction of the model. So using home data frame, we are selecting the features and storing it in a variable capital X. Then using train test split function, we are splitting the features and predictors. Here random state is equal to 1. Randomly samples are selected, but every time the output which is produced will be same on different machine also. So we have divided our features and predictors into train X, val X, train Y, val Y. Then using decision tree regression, we are creating a decision tree model, storing it Iowa model. Then we are fitting this model to the train data, train X, train Y. Using the train model, we are predicting it the values of the train model on validation data val X, store the prediction in val prediction variable, computing the mean absolute error by calling mean absolute error function on val predictions, comma val y, where these are the predictions and these are the actual values of y for validation data, which will give our validation mean absolute error, and we will print that error on the user screen. The following 4 codes is for checking whether the code is running correctly or not. Setting up environment for code checking of this exercise. Last 4 lines. Exercise: you would write a function get MEA yourself. So we have to write a function. For now we will supply it. This is the same function we have read about in the previous session. Just run the cell below. You have defined getMEA function. It is receiving one argument as parameter, maximum leaf nodes, train X, val X, train Y, val Y. We are creating decision tree regression model, giving it a parameter keyword argument maximum leaf node is equal to maximum leaf nodes, which is received as a argument to the function. Random state is equal to 0 to produce same result on different machine also. We have created a model with the maximum leaf node as one parameter to the model. Then we fit the model to the training data, model.fit train X and comma train Y. Then we predict the train model on the validation data. So we make prediction using features val X. Those prediction are stored in predict underscore val variable. Using mean absolute error function, we are comparing our predicted values with the actual validation predictions. So this will give mean absolute error, and we will return that mean absolute error to the user when the function is called. Click on the cell and run the cell to create the function. Now we will step 1 compare different tree sizes. So we will create different sizes tree with leaf node, different number of leaf nodes. Call the mean getMEA function. We will compare the errors and will decide which number of leaf node tree is what are the number of nodes on the leaf node should be used to get minimum error. So Write a loop that try following value of maximum need node from a set of possible values. Call the getMUA function on each value of max leaf node. Store the output in some way that allows you to select a value of max leaf nodes, then give the most accurate model on your data. So we are creating a list which will iterate for max leaf node 5, 25, 50, 100, 250 and 500. Then we will using comprehension, we will compute the value for every leaf size in candidate max leaf node. We are iterating over this list. We are selecting each leaf size. Then we are calling getMUA function by passing leaf size, train x, val x, train y, val y. This will return the MEA score. So, and we are creating a dictionary of leaf size and MEA score. So we have written a dictionary comprehension function. We iterate over each leaf size variable inside the candidate max leaf list. Then we call getMUA function by passing leaf size, train x, val x, train y, val y. The score is written, which is stored as a key value pair leaf size colon score. So after execution of this statement, you have a dictionary of leaf size and their scores. We will select the minimum mean absolute error leaf size. So what you are running inbuilt mean function on scores, this dictionary scores, and the key is scores.get. So we will get all the scores using scores.get, and we will select the minimum score, and we will store that it is a best tree size. You can print the best tree size and say that many number of nodes if I use for model creation of the tree, that model will be accurate. Click on the cell and run the cell. You can see our solution is correct. Now you can, if you want to see what was the best leaf size of the leaf node, you can print best tree size. You will copy this best tree size, select it and press Ctrl C. Below the cell, paste it and print it. You get best tree size as 100. So for a 100 leaf nodes, your model will give higher accuracy. Fit the model using all the data. You know the best tree size. If you are going to deploy the model in practice, you will make it even more accurate by using all the data and keeping that tree size. That is, you need to hold out the validation data now that you have made all your modeling decisions. So we are creating a final model using decision tree regression. We are giving max leaf node as a best tree size and random state is equal to 1 for repeating the results. You have created the final model. You have fit the final model on the complete data. Model.fit complete feature X and complete predictor Y. This model is created. We'll check the solution is correct. You have tuned the model and improved your result, but we are still using decision tree model, which are not very sophisticated by modern machine learning standard. In the next step, you will learn to use random forest to improve your model even more. That's it for this video, where we have seen how to get the best model using a getMUA function which iterates over a list, pass that iterating element as a parameter of a leaf node of the tree, and compare the accuracy to select the model. Thank you. Thanks for watching. Do hit that subscribe button for more such technical content. See you in the next video.